Okay, these notes are for, really they're for the intro and the first day of section 1, so I'm going to label that accordingly. You'll see in these notes there's not as many problems to work through as much as there is, just kind of some concepts that you saw in the introduction, to talk through and kind of expand on. Here's the first one of what I'm talking about. Okay? In statistics, we will cover two types of variables, and this will come up all year, that you should be able to identify which one of which that we're working with. Okay, for quantitative, be ready for this. I like using the name numerical. It means the same thing. It means the measurement that you're taking can be described with a number. Okay, if you were to ask somebody their age, you're talking about a numerical variable. The response that you would get would be a number. Okay, categorical, and again, you could say quantitative if you want. That's just, the root there is quantity, which is the same as a number. I think numerical just says it better, and I like using that term. Categorical means you're placing somebody into a category or a quality. All right, stick with another really, really basic. There's other examples on here, okay, but one that helps, I think, quite a bit is if you're to ask somebody their gender, right? They're not going to respond with a number. They're going to give you a quality or a category, so some category that you could place them into, okay, male or female. All right. Individuals are who is described in the set, and the variable is a characteristic of that individual. Okay. Now, right along this page, I want to say it's on page 6. It's more of a big deal in chapter 2. But I'm going to throw it out there now that you should start to get to know it. Because it's covered in the introduction. Be sure to check out the definition of a distribution. Okay? I want to say it's on page 6 in your book. A description about a variable of the outcomes that it can take on and how often it takes them. Okay? What are the possible measurements that your variable could have? And then, of those outcomes, they probably don't all occur at the same frequency. They might, they might, but they might not. Which ones occur more frequently than others? Start to get to know that definition. Really, really, especially in chapter 2. Big deal. All right, here's a big set of data just on some census information. The individuals are the 10 residents. Okay, those are, those are the people that were included. All the information in here is about them. Okay. Here's the same table. All right, but let's go through this. Just getting used to identifying variables, because each little column that we have is a variable, right? It's a response from these 10 individuals that isn't necessarily the same. All right, we're measuring what those responses are. For categorical, start in that very first column. How about the state you're from? If you were asked what state are you from, you're not going to respond with a number, right? Keep in mind over here, just to get you used to both, I keep throwing both terms on there. In time, you'll see I'll really prefer the term numerical. Number of family members. If somebody was asked that question, you're expecting a number as a response. Maybe their family is so big, they're just like, I don't know, a lot. No, I'm just kidding. That's probably not going to happen. Even if you have a lot of family members, you probably have a number as to how many. Let's see. Let's keep going. I'm going in order left to right here. Age. I should bullet point these so you can tell them apart. Gender. That's going to take us back to categorical. Marital status. It's categorical. Well, what do we got left here? Total income. I'm expecting a number. Probably some level of thousands of dollars or tens of thousands. And travel time to work. Probably a number measured in minutes. Okay. One little side note with categorical and numerical data. When we really dive into, oh boy, really the heart and soul of statistics, which is kind of chapters 6, 7, 8, and 9, you're going to see for a huge chunk of the semester, we work with numerical data. We don't really dive into categorical until chapter 11, which is all the way to second semester. It's kind of one of those weird things that catches you by surprise, where it's like all semester we're working on these various problems, and if you're really, paying close attention to it, you're like, do we ever work with qualitative data? Yes, we do. Okay, but we kind of go in order and we hit numerical first. Oh, here's all the different characteristics, all those variables about the person from Kentucky in the first row. Here was one to try on your own. I just have the answers here, obviously. Maybe you already tried it. If not, you can just treat it like notes. Here's an interesting one. Sometimes we always get caught up that we say the individual is a person, and that's not necessarily true. All this data are about degrees. Okay, so the degrees themselves are the individuals. Right? Those are the basic entities that are being measured. Okay, not necessarily the person that they're awarded to. The major, that's what's being measured in part B. The middle column displays the frequencies, and then the last column displays the percents. Another concept to talk through here. This is one that, again, kind of like a distribution. Hugely important, but isn't necessarily going to be a huge factor in Chapter 1. But in time, this is a huge idea, and it's one that you're probably not super familiar with. Statistics is all about this idea that we have a huge set of data, and we call those sets populations. And they tend, if we're going to use statistics, it tends to be because that population is impossibly large, impossible to measure everybody. So what do? We take a sample. We randomly select a smaller subset that if we did the sampling well, it should be like a little mini population. Okay? We collect data from a representative sample. And that is the information that we'll analyze, that sample. Okay? And there's a few things we need to know there that even if we sampled randomly, it might be really close to the measurement for the population. It might be a little bit off. Okay? I'm not going to get into the ins and outs of how all that stuff works, but we will get to this idea like crazy throughout the semester. instead of working with the whole population. You can do that. It's called a census, okay, where you want to go take data on everybody. They're very time consuming, depending on the size of the population. If it is really large, it's time consuming, it's expensive, it's impractical, right? The only time it ever really comes up is like the U.S. Census every 10 years when everybody has to be counted, which doesn't use sampling because the Constitution mandates that it has to be the direct count of everybody. So more often than not, we prefer samples. I'll leave it at that. Oh, that's an activity that we may get to in the first week of class. Let's make a bar graph. It's going to be a part of a little bit of chapter 1. All right, notice on the bottom here, we'll in a little bit we'll get to histograms, but right now we're just sticking with bar graphs. All I'm doing here, but on a bar graph, the bottom row is going to be a characteristic or a category. Okay, it's a category. So for a cell phone, I'm going up to 85%. Now in a bar graph, I should have gaps between them. Oh, the old MP3 player. You may actually still have one of those. It's just in your phone somewhere, all these different devices. The names sound funny these days, but I don't know how, when you have music on your phone, I don't know what file type it stores it as, but, it's interesting to think that all these things, like an MP3 player, you probably have the equivalent of it, but, the more common approach today is that you've got a phone that does a billion different things, and they're all combined into one. Like even has some video games on it. A laptop, up to 38%. The portable CD and tape player, my favorite. Gotta have that. Down to 20%. This is from a few years ago, so it's probably even lower than that. And the next couple questions are just a few follow-ups about that, the whole cell phone and MP3 players. Again, you probably have those two in one, but those are overwhelmingly common. The portable CD or tape player, they're fading. Pretty small. A pie chart would not be appropriate here, just largely because a pie chart altogether has to represent a whole. These percents don't apply to that, so they don't all add up to 100. So pie chart, no good. Oh, be aware of this. You'll see this all the time. First of all, this should say 81. We'll kind of be aware of this stuff when graphs really aren't very good. The heights of the bars are nowhere close to proportional. 81 to 95 only has a difference of 14, but still, based on the size of the bars, it looks bigger than 81 to 56. That makes no sense. And then this is an ad for DirecTV, so that DirecTV bar is extra wide. So it's with the intent of kind of making the whole 95 channels from DirecTV. Excuse me, not just 95 channels, 95 of your favorite HT channels. How does DirecTV know my favorite channels? Maybe they did a survey. I don't know. Anyway, be aware of that. Those kind of problems can come up in homework when, it's not good or whatever. That the graphs can be misleading.